Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on chapter 4 of Oracle's documentation on Java native interface. So accessing static fields. So let's bring up my lectures on the accessing fields. We said that first we need to have a J class reference so that JVM knows which class we're talking about. And then we have to get the field ID so that JVM knows which field of that particular class we're talking about. And for static fields, we use get a static field ID, and then we pass the J class, the name of the field, and the signature. The reason that we both need the name and signature is that different fields can have the same name if their type is different, right? So signature is basically the type or the fully qualified type. It could be a primitive or a Java object. Get a static field ID, it returns a J field ID, and then takes the J class, const char pointer name, so a string literal or a C style string as the name, and const char pointer signature, which is basically the type of the field. Returns the field ID for a static field of a class. The field is specified by its name and signature. The get a static type field and set a static type field families of accessor functions use field IDs to retrieve a static fields. So get a static type field. Type can be any primitive. If the field is a Java object, we use get a static object field, which means get a field that is a Java object and it's a static field, right? And obviously when we have a get, we also have a set function to set the value of that static field. Get a static field ID causes an uninitialized class to be initialized. Linkage index for 144 in the JNI environment interface function table. And then the parameters, again in C++ we don't have these parameters. This is another level of indirection that we need in C, but we don't need it in C++. It takes a J class, a Java class object. The name is a C style a string, basically a string literal. The static field name in a 0 terminated modified UTF-8 string. When we say 0 terminated, 0 means a null termination character, \0 as a character. Signature is the type of basically the fully qualified type of that field. The field signature in a modified UTF-8 string or a C style string, and it returns a field ID or null if the specified static field cannot be found. So if we pass in a field that is not found, that is not available, obviously in C++ it returns a null, which is a C macro for 0 pointer, null pointer. However, in C++ it's better to use null pointer keyword, right, from C++ 11. But because they wrote JNI in many years ago, before the standards of C++ 11, they're just using this null macro from C. And obviously if we cannot find that field, it has to also throw something on Java stack, so no such field error if the specified static field cannot be found. And this is thrown when we return back to Java. So if we don't check for any exception and we just get this and then immediately return, if the field was not found, then in Java this error will be thrown on the Java stack. Exception in initializer error, because it can in fact initialize a class. So if the class cannot be initialized, if the class initializer fails due to an exception. Out of memory error, if the system runs out of memory. The reason this can happen is because static fields are class level fields, which means we don't need to construct an instance of the class. We directly access that field inside a class, right, because it's a static field. However, in order to access that, the JVM needs to first load that class into the memory. And if the JVM runs out of memory and cannot load it, then it throws an out of memory error. Get a static type field routines, and again we have type can be a primitive, right, int, float, double, line, boolean, or it can be an object, right? If the field is a Java object, it's not a Java primitive, we use get a static object field. So native type, get a static type field, it takes a J class and then J field ID, and then it returns a basically it returns it returns the basically the the corresponding type in C++ for that field. If it's primitive, obviously it directly maps to the C++ primitives and we can immediately use it. If it's a Java object, if the field is a Java object, i.e. when we use get a static object field, then it returns a J object, so we cannot immediately use it, right? So we have to use other functions to talk to JVM about that object. This family of accessor routines returns the value of a static field of an object. The field to access is specified by a field ID, which is obtained by calling get a static field ID. The following table describes the family of get routine names and result types. You should replace type in get a static type field with the Java type of the field or one of the actual static field accessor routine names from the table, and replace native type with the corresponding native type for that routine. Get a static type field family of the accessor routines. If the field is an object, a Java object, we use get a static object field and returns a J object pointer, right? And then, for example, if the field is a string, let's say in this example I have name as a field which is a string and it's static, when it returns a J object, I can immediately cast it to basically J string, right? Note that in C++, J string is a subclass of J object. In C, J string is a type def of J object. In both cases, we can do typecasting. That's fine. There is no problem. And again, all the primitive types map directly to the C++ primitive. So as soon as we get the field, we can start using it, because C++ has no problem working with that. J object is different because this is a pointer. These are all primitives. J object is a pointer. And then we have to, again, talk to JVM to get more information about that object. All right. So get a static boolean field, get a static byte field, get a static char field, get a static short field, and then int, long, float, and double. And linkage indices in the JNI environment interface function. Get a static type field family of accessors. Object is 145, boolean 146, byte 147, char 148, short 149, int 150, long 151, float 152, and double 153. And the parameters that these get a static type field get, they get a J class, a Java class, so that JVM knows which class we're talking about, and then a field ID, and so that the JVM knows which field we're talking about. Note that if the field is not a static field, we saw that we use get type field. For a static fields, we use get a static type field, right? For a static field, we pass a J class because static fields are class level variables or class level fields. For non-static fields, we pass a J object because they are instance fields, right? They are field that is associated with each particular instance of that class, right? So you have to be careful when you use get a static field. You have to pass a J class, not a J object. And these functions return the content of a static field. Set a static field, again, setting object fields in C++, it could be a static, so we use set a static type field for primitive types, or set a static object field. And then what we need to do, now obviously when we want to change it, first we have to give JVM the J class and then J field ID, so that JVM knows which class and which field we're talking about. But then we should also give the value that we want JVM to pass into that, right? So for example, in this case, I have an int age, and so I say J field ID, get field ID, age integer, and then set field, set int field for primitive types, and then J object for the non-static fields. For static fields, we pass a J class, and then the field ID, and then the value. If it's a primitive, we can pass a J int, which is basically a C++ primitive, which is int. If it's a string, for example, a Java object, we have to pass a J object. In this case, I'm creating a, we can create a basically a J string object or J string pointer, and ask JVM to create a Java object and give us a pointer to it in C++, and then pass it here to change the value of this name field, right? Set static type field takes a J class, J field ID, and a native type, right? And it only takes one value because field has one value. If it's an object, we have to construct that object beforehand and then pass a J object pointer here. This family of accessor routines sets the value of a static field of an object. The field to access is specified by field ID, which is obtained by calling get static field ID. The following table describes the the set routine name and value types. You should replace type in set static type field with the Java type of a field, primitive types, or object for fields that are Java object, or one of the actual set static field routine names from the table, and replace native type with the corresponding native type for that routine. So set static object field, it takes a J object. Boolean, JBoolean, which is a C++ primitive, all of these we can immediately use them because these parameters are C++ primitives. For objects, we have to construct a Java object beforehand and get the J object pointer, and then basically pass the J object reference or pointer to this set static object field. Set static byte, char, short, int, line, float, double. Linkage indices in the JNI environment interface function for set static type field. It starts from 154 for the object, goes all the way to 164. And all these set static type field get a J class because we are talking about a static field, and a field ID, so JVM knows which field we're talking about, and a type, which can be a primitive type or a J object pointer, a pointer to a Java object. Calling static methods, and again methods, we've seen that calling static methods, again J class, so that JVM knows which class we're talking about, and then get a static field ID. We need a field ID, and because it's a static method, we have to use get a static method ID, right? We have to get a method ID so that JVM knows which method we're talking about. And then we have to use the call static whatever type method. And methods, so fields are described by their type, right? Methods are described by the type of their return value, right? By their return type, whatever the type of the return value is. If it's a string, if it's a primitive, if it's a Java object. Get a static type method, this type or object if the return type of a method is a Java object. For methods, the type is basically the return type. So J method ID, get a static method ID, we pass in a J class, const-char pointer name for the name of the method, and const-char pointer signature. And again, the reason that name is not enough is because Java allows method overloading. So different methods or methods with the same name and different parameter signatures are valid overloads, and because of method overloading, the name is not enough to uniquely determine which method we're talking about. And the signature of a method is the signature of its parameters in round brackets, and then the signature of the return type. For constructor, the return type is void, but we never use a static method ID for constructor. So constructor is never static. So returns the method ID for a static method of a class. The method is specified by its name and signature. Get a static method ID causes an uninitialized class to be initialized. And again, that's because whenever we access or call a static method, JVM needs to load that class into the memory if the class has not been loaded, or basically if the class has not been initialized. Linkage 113 index, and then takes as J class the C style string or string literal, and then a C style string for the signature, and it returns a method ID or null or basically a null pointer if the operation fails. Can throw a no such method error if the specified static method cannot be found. Exception in initializer error if the class could not be initialized. Out of memory error if JVM goes to load the class into the memory but then it runs out of memory, right? Call a static method routine and the method A, which takes an array of J values, or V, which takes a VA list. And we've seen this before, so I'm not going to spend much time on this. So method, it takes an var variable argument. We have to manually pass them as a comma separated list. J value pointer, which is a array of J values, and VA list is a struct that can hold any number of values. This family of operations invokes a static method on a Java object according to the specified method ID. The method ID argument must be obtained by calling get a static method ID. The method ID must be derived from class, not from one of its super classes, so specifically from that particular class. And we've seen that there are non-virtual versions. However, for statics, I believe we don't have non-static versions, and we don't have non-virtual versions. So call a static method. So programmers should place all arguments that are to be passed to the method immediately followed by method ID argument. Obviously, they're separated by comma. Call a static type method routine accepts these arguments and passes them to the Java method that the programmer wishes to invoke. Call a static type method A takes an array of j values. Programmers should place all arguments to the method in an args array of j values that immediately follows the method ID argument. And then V, they have so it takes a VA list, variable argument list. Should place all arguments to the method in args argument of type VA list that immediately follows the method ID argument. The call a static method V routine accepts the arguments and in turn passes them. Okay. The following table describes each of the method calling routines according to their result types. You should replace type in call a static type method with the Java type of a method or one of the actual method calling routine names from the table, and replace native type with the corresponding native type for that routine. So call a static void method. Okay, so void here for methods. For first of all, for fields, we don't have a void, right? So fields cannot be void of type void, right? Or primitive type void. However, the return type of a method can be void, and or the list of parameters can be void. So if a method doesn't take any parameters, the signature of the parameters is just empty round brackets. We don't write capital V for void, right? We just write round brackets. However, if the return type is void, for the signature we use capital V, which signifies, hey, this method return type is void. And then when we want to call it, we said that for methods, the function is determined by the type of the return value of the method. If the return type is void, we use call a static void method, or void method A, void method V, and the return type is void. Call a static object method, it means call a static method that returns a Java object. So it returns a J object in C++. Call a static Boolean method, it means call or invoke a static method that returns a Boolean, a primitive Boolean, and it returns a J Boolean. Similarly for byte, char, short, int, long, float, and double, right? These are all primitive types, very easy to work with. The J object is a little bit more difficult to work with in C++ because it's a pointer, right? It's not a primitive type. And linkage indices in the JNI environment interface, they start from 141 and 114, 117, 20, 23, 26, 29, 32, 35, and 38. And all these get a static type methods, they take a J class and J method ID, or basically these call a static methods. They take a J class, J method ID, and a list of parameters in type of arguments, comma separated, or a array of J values for the one that ends with A, or a VA list type that is a strike that holds some number of J values, right? And returns the result of calling the static Java method and throws exceptions raised during the exception of the Java method. All right. So these were all more advanced topics. Let's go back to strings and strings. All right, working with strings, and we've spent quite some time on explaining in my lectures what are the differences between Java strings, C++ strings. C+ has a string class, and then we also, because of backward compatibility, it also accepts raw strings, which are C style strings, and C style strings are character arrays, right? So first of all, we cannot use std string, the C++ string class, right? Java strings are UTF-16. They're not compatible with C style strings in C++ or std string, right? But then we can use this new string function in JVM, in JNI in environment interface, and pass a C style string, const char pointer, and then J size length, right? Actually, new string takes a UTF-16. Remember, jchar is unsigned short, which is 2 bytes, right? So new string takes a const jchar pointer, Unicode characters. It's a 2 byte, and then j size, and the length of the, basically this is the pointer, which is a character array, right? And then we also have to specify the size, because when you pass a pointer, it doesn't know the size, how many jchars should it read from this position. This is the start position of the array, so we have to also pass as j size. And remember, j size is a type def of jint, so it's not size t, so don't pass a size t type here. And again, that's because size t, I believe, wasn't available when they actually wrote the first version of the JNI. So they're just passing an integer, a signed integer, not a size t type. This constructs a new Java lang string object from an array of Unicode characters. And again, the problem is that the C++ source code is UTF-18. So most compilers, most C++ compilers don't accept UTF-16 characters in their source code. So this is not easy to work with. Now, obviously, we have another type, which is a new string UTF, and then takes a const char pointer or a C style string or a UTF-8 string or a modified UTF string. Linkage 163 takes a Unicode chars, an array of jchars, pointer to a Unicode string, and the length of the Unicode string. Now, the question is, should you include the null termination in this length or not? And you can try to see whether you should do it or not. I mean, I think we shouldn't, right? But you can try it for yourself. Returns a Java string object or null if the string cannot be constructed. And obviously, because we're creating new objects, Java strings are objects, JVM can run out of memory and throw a out of memory error if the system runs out of memory. Get a string length, we have used this before. Get a string length basically gets the length of the string, of the Java string. Obviously, it doesn't account for null termination, right? Get a string length, we pass a j string pointer, which points to a Java string on a Java heap, and it returns a j size. And again, this doesn't return a size t, right? In modern C++, all these length is always described by the size t type, but in JNI interface, length is described by j size. And j size, if you look into the jni.h header file, you see that j size is just a type def of jint, and int is just integer, so it's a signed integer. Returns the length, the count of Unicode characters of a Java string, right? Unicode, so this is different again. This is basically the same as we invoke the length on a Java string in Java. Index 164, and it takes a j string pointer, right? A j string reference, and returns the length of the Java string. Get a string chars, it returns Unicode characters, so const jchar pointer, 2 bytes, right? An array of 2 byte jchars. Get a string chars, it takes a j string, and a j boolean is copy. And if you are wondering why we have this j is copy, is because basically the question is whether JVM behind the scenes create a copy and gives us a pointer to a copy. Remember, whenever JVM and any JNI function gives us a raw pointer, like jchar is a type def of a primitive type of C++, right? Whenever JVM gives us a raw pointer, then first of all, there is a release function that is associated with that. So whenever we use a get function that gives us a raw pointer, we have to eventually call the dual function that starts with release. Second, there's always this question whether this pointer is pointing directly to that object on the Java heap. It's a direct pointer, or JVM made a copy and gave us a pointer to the copy of the original one, right? And we discussed this in depth when we talked about critical access to strings, right? Critical access to a string. We said that get a string chars, basically get a string UTF chars or get a string chars, it gives us a pointer. It can be a const char pointer or const jchar pointers, right? If we say UTF chars, it converts to UTF-8. So it gives us a const char pointer C style string. If we say get a string chars, it gives us 2 byte, an array of 2 bytes J chars. This is UTF-16. But then when we tested it, we saw that is copy comes back true, which means this is not a critical operation or critical access. JVM doesn't give us control, doesn't give up control, and JVM is actually cloning the original string. And again, a string behind the scene manages a character array, and a character is a built-in type, right? A primitive type. So JVM knows how to clone primitive array types. So JVM has no problem copying strings or cloning them, right? So when you use get string chars, JVM actually copies the original string, creates a new string on the Java heap, and gives us a raw pointer to the copy, right? And again, the problem with all these jchar pointers is that none of the C style functions, string functions, they are in the C string. None of them are working with jchar, right? So if you pass a constant jchar pointer to stdc out, it just prints the first character because this is 2 bytes. The first byte is compatible with the UTF-8 char. The second byte is 0, which the stdc out just assumes it's a null termination. So if you pass an array of jchar pointers to the stdc out, because stdc out, the insertion operator is overloaded for const char pointer UTF-8, right? So stdc out doesn't understand const jchar pointer, and jchar is just two bytes, right? So the first byte is just the character, right? If you use English, UTF-16 is backward compatible with UTF-8, so it occupies the first byte, or basically ASCII. English is ASCII, so it's just 7 bits. It's not even 8 bits, 7 bits. The rest are zeros, so the second byte is 0. So when stdc out iterates over the number of chars or bytes, the second byte is 0 and it assumes it's a null termination. And again, this whole business of jchar pointers in C++ is messy. So I always recommend to use the get a string UTF chars and directly ask JVM to give you a const char pointer. So JVM basically creates a copy and then converts that jchar array to a UTF-8 character array, and that gives you a pointer to copy. The problem was that when we wanted to use a get a string critical, it always gives you a const jchar pointer, which is a little bit messy again because const jchar pointer is not compatible with const char pointer. So you have to manually write a couple of functions to handle this, right? So returns a pointer. So get a string chars returns a pointer to the array of Unicode characters of the string. Remember, it returns a raw pointer, so we have to call the release string chars. This pointer is valid until release string chars is called. If is copy is not null, if null is basically a 0, right? That's why we usually just put 0 here. If we create a JBoolean object and pass it JBoolean variable and pass its reference here or its address, then JVM can modify it and give us information whether it's actually making a copy or not. And again, this is JVM dependent, but almost 100% of the vendors out there that have JVM, they just use the original implementation, and therefore this is copy is always comes back true. If is copy is not null or 0, then is copy is set to JNI true if a copy is made, or it is set to JNI false is if no copy is made. And again, we tested this with the get a string UTF chars, which is the same, similar to get a string chars, and we saw that the is copy comes back true, which means this is not a critical access. JVM is making a copy of the original string. And this business of just making copies, it's very inefficient in general, right? Index 165 in the JNI interface function table. Obviously, it takes a JString reference and an is copy. It's optional. We can put null pointer here because remember, it takes a basically is copy JBoolean pointer. So we can put a null pointer. In modern C++, we use null pointer. Before C++ even, we just use null C macro, which is 0, right? A pointer can never be 0. So index 165 returns a pointer to a Unicode string or null if the operation fails, right? Release a string chars takes a J string and then const jchar pointer chars. And we saw that when JVM makes a copy, so if we modify this J character array, and again, we cannot really modify it because basically it's a const jchar, right? So we cannot modify it. So when we call release, the only thing that JVM does is call a delete on the basically on the it calls the delete on this original character is on this copy and just destroy it. Informs the VM that the native code no longer needs access to chars. The chars argument is a pointer obtained from a string using get a string chars. And again, this points to a copy, not the original string array, right? Not the original character array that this string object is managing. Index 166, a string is a Java string or a J string type, right? And then const jchar pointer is a jchar array, a pointer to Unicode string, new string UTF, and this is what this UTF ones, which are what we're typically working with. They make life easy because they directly return us a UTF-8 array, so we can pass them to the CS string functions, the functions that are inside the CS string headers, or convert them directly to the std string because it has a constructor that accepts a const char pointer. So let's go back to the strings again. All right. So new string UTF, we pass a CS style string, which is a const char pointer. And remember, we cannot pass a std string. So what we do with std string, we call the C underscore str, and this returns a CS style string out of this string object, out of this std string. Okay. So if you have a std string, you can call the C underscore str. It returns a const char pointer, and then we can put it inside this new string UTF. And this gives us a J string reference, right? So we ask JVM to create object and a string, a Java string, and give us a J string reference. Constructs a new Java lang string object from an array of characters in modified UTF-8 encoding. Index 167, and then it takes a const char pointer or bytes, the pointer to a modified UTF string, and returns a Java string or null pointer if the string cannot be constructed. And the only way that it cannot be constructed is when the JVM runs out of memory. So it can throw an out of memory error. Get a string UTF length. Get a string UTF length, and again this gives us the we pass in a J string, it gives us the length in UTF-8, returns the length in bytes of the modified UTF-8 representation of the string, right? It returns a J size is a type def of JInt. Index 168, it takes a J string pointer and returns the UTF-8 length of the string. So if we don't use UTF, if you use basically get a string length, basically it returns the length in UTF-16. So if we use get a string UTF length, it returns the length in modified UTF-8. Get a string UTF chars, and again this is what we typically do to get a CS style string, something that we can immediately work with in C++, right? So we say this J string extract a const char pointer out of it. Remember, this is not jchar, this is char, so this is UTF-8, and we can immediately start using it with all the functions inside C string header file. Get a string UTF chars, it gets a pointer to J string reference, and a J boolean is copy, and this always comes back true, which means this is not a critical access, right? So JVM behind the scenes create a new copy of the original string, converts it to basically from jchar to char array, and then gives us a pointer to the beginning of that copy. So this is always copy, always copy. That's why it's very inefficient. Returns a pointer to an array of bytes representing the string in modified UTF-8 encoding. This array is valid until it is released by release a string UTF chars, right? Release a string UTF chars. And again, what happens here is that nothing is modifiable here because strings are unmodifiable. This is a const char, right? This is a pointer to a const character array, so we cannot modify anything there. So the only thing that happens when we call this release string UTF-chars is that JVM deletes that copy, and this pointer is not valid anymore, right? If is copy is not null or not pointer, or it's not 0, we typically pass 0, right? Or we can, in modern C++, we have to write null pointer here. If is copy is not null, then is copy is set to JNI true if a copy is made, or it is set to JNI false if no copy is made. And I hope you take my word for it that we tested it, and this always comes back true, right? Which means JVM always makes a copy. This is not a critical access. The only time that JVM doesn't make a copy is when it's a critical access, right? That's the rule of thumb that you have to remember. Index 169, JString is a Java string, and is copy a pointer to a JBoolean, returns a pointer to a modified UTF-8 string or null pointer if the operation fails, and when it fails, it means we ran out of memory or something else happened. Now, obviously, there is another one, release a string UTF-chars, right? And this is the dual function to the get a string UTF-chars. Again, a JNI function gives us a raw pointer. What it means is that we have to call the release on it. And then we pass the JString and const char pointer UTF, and the only thing that happens here is that it calls a delete array. It's an array delete on this thing, and that's it. Informs the VM that the native code no longer needs access to UTF. The UTF argument is a pointer derived from a string using get a string UTF-chars. And remember, it's a copy. It always is copy, right? A pointer to a copy. Index 170 takes a JString and a const char pointer, a pointer to a modified UTF-8. Note, in JDK 1.1, programmers can get primitive array elements in a user-supplied buffer. As of JDK 1.2, additional set of functions are provided, allowing native code to obtain characters in Unicode, UTF-16, or modified UTF-8 encoding in a user-supplied buffer. See functions below. All right, so I think that's enough for this lecture. I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.